Hey folks, I'm Chuck Black. We're doing 52 weeks of Python. Actually, we are extending 52 weeks of Python. We're adding some functionality as I add it to this thing that I'm calling quokka-prime just for now. I'm not sure what I'll eventually call it, but I'm extending this little implementation of Quakka that we did throughout our weeks of 52 weeks of Python. And this Quakka thing that has become much bigger and more robust, has more functionality. We are this week going to be talking about adding packet capture to the list of features that exist in our Quakka type product. So that is what we will be discussing. We'll be looking at the Quakka server and the endpoints that were implemented in order to cause this to happen. We will be looking at the messages that we send to tell the worker to initiate capturing of packets. We'll talk about APIs that come in and that save data to the database and that make requests from a user interface to get data from the database. Now, if you think that you understand this because you did this with Quakka or you saw me discuss this with Quakka, I have news for you. We're doing this with MongoDB, so it's an entirely different way of doing database and access and saving, etc. So you may want to pay attention to that just to understand how to do it in a NoSQL type of database rather than in an SQL database. So that is what we will be talking about, and hopefully that will be of interest to you and you'll come away with a better understanding of how to add packet capture to our Flask Quakka server. So let's get started. Okay, so let's talk about adding packet capture to our Quakka implementation. I'm calling it quokka-prime in my new repository. We were calling it mini Quakka before. Let's take a look at what the foundation of this implementation of Quakka is so that we understand the difference between the original Quakka, which if you followed along a little bit with the functionality that I was showing you, it was implemented in this manner. Now our new implementation looks something like this. This is from a while ago, this picture, so I've added stuff to it, as we'll see in this slide over here on the right in just a second. But you can see over here everything in terms of this implementation of device discovery and monitoring and compliance, hosts, services, summaries, etc. This is all what we would say is tightly coupled. Over here, everything is loosely coupled. That is, we have monitoring functionality, but we've taken it out of the internals of the product and made it an independent entity. And we're using a RESTful API to update that data in the database. So this, we would call this loosely coupled. That means I could swap out whatever this is, I could swap out whatever that is, and the other entity didn't need to change. So loose coupling is quite often a good way to develop software. But this is what we're working with. We've obviously evolved it since then, and in fact this picture is a decent representation of what we have. Most recently we talked about unit testing, but right now we're going to talk about adding packet capture. So you can see the boxes in green. We're going to need to have this capture functionality implemented. Now, as you can see down here from this other slide, I did have a capture worker in the original Quakka. I will be porting that and using it pretty much intact, just the way I did the port scanning and traceroute functionality. So there's not a lot of changes there. The database, there's going to be a table that holds the captures. So you would initially think, there's not going to be much change there. But remember, this is implemented using Mongo as the database. Before, we were using, as you can kind of see here, we were using SQL Alchemy. And so this is an SQL database, which, as we recall from our discussion of databases, is entirely different in the manner and the philosophy of storing stuff. So that will be an interesting discussion when we look at the details of how we do that. What's not in green, I'm not sure why I don't put these in green, but we just so that you're aware of it, we will be adding new REST APIs. There will be REST APIs for the user interface that requests a packet scan, as well as for the packet capture functionality here. The worker needs to send the data back to Quakka to be stored in the database. So there would be two individual APIs, and so the REST API will change, and as well the user interface will need to change. And so we will be showing you that about changes there now. If we were to look at my Quakka, this is the newer implementation of Quakka. If I was to say, okay, well, I want to do a packet capture, I've actually already done one, so it goes to the database and sees that I've already done one. If I wanted to start one, I could start it right now, and we will definitely do that, and we can look at the worker that I have sitting here waiting for packets to arrive. It's not really, it's waiting for requests to do packet capture or to do port scans or to do Traceroute, so it's not really doing anything at this point in time, but we will show that. And this is what the packet capture looks like. If you haven't seen Quakka and what it can do, then this is basically all it does. Don't get too excited. It's not like Wireshark where you can individually go and expand each one of these things. I'm basically doing a pre-print of the packet that I get back from doing my sniffing, and then I've also taken and done a hex dump and printed it next to the ASCII version of it. And so it's not like your Wireshark or anything like that. And I also, as you can see, when I update it, I don't leave this open, so I haven't implemented anything to detect that this is open. That's kind of a user interface type thing, and I'm not spending a ton of time on the user interface. But you see, in general, that's what it is. This is what we are talking about when we say that we're going to implement in this type of model, this type of philosophy in terms of how we do things. Packet capture, that will be the worker, the database, the REST API, and then the user interface. So that's what we will be looking at. Okay, so let's start looking at the code by looking at the REST APIs that have changed. Everything makes use of this REST API, whether it's the user interface or the worker that's sending data, or even when things get stored out to the database. It all goes through this piece of code here, the REST API. So let's go ahead and take a look at that first. So let's just to kind of level set your brain, we're in this Quakka server module, which is where, if you recall, put your minds back to when we were first doing this, we had implemented this host endpoint, and all it did was it returned all the hosts, or we also had the ability to update a particular host. So this is the hosts endpoint that we've had for many, many weeks now. The same thing is true for devices. The same thing, we can get all the devices, or we can update a device. Services, we can get all the services, or we can update a service. Now we get to some stuff that we've done more recently. Remember, we implemented port scan, and so for port scan, we have a new endpoint, and this new endpoint allowed us to initiate our port scan. So we did a start port scan, and then the user interface, or whoever's getting at the data, the results, would call into this get port scan functionality. And all of my three items that you see, let's see, is this what I want to look at? These three pieces of functionality that I've implemented, the way that they work is fairly similar in that you initiate them, which is what happens when you start it, and then you go and get it, and that waits for results to come in the other two situations. Ours, for packet capture, is going to be a little bit different. In addition to this scan endpoint, I have a endpoint called worker/port scan. Don't ask me why I called it port scan rather than scan, just because I'm a doofus probably. But this is, if you recall, this is what the worker uses. This is port scan. This is where the data gets sent in so that it can then get saved in the scans table in the database. So that we have the worker endpoint as well. And it's going to be the same thing for Traceroute. Traceroute, again, we have a get, which is what attempts to get the Traceroute information. And then down here, we're going to be starting the Traceroute. And then down below it, we have another endpoint, which is the worker endpoint. Again, this is where it sends the data in, and we record that data. So here we are, we've arrived at capture, and capture is going to be pretty much the same. There's going to be a get endpoint, and there is going to be a post endpoint, and the get is eventually going to, this is the get which happens chronologically second. It's going to be getting all the packet captures from the database. The thing that happens first is somebody requests, in our case it's a packet capture, and so what we would be doing is we're starting the capture in the same way that in the previous two endpoint sets we had a start port scan and we had a start traceroute. And then in the same way as well, we have a worker endpoint. This is where the packets get sent in. I will tell you that packets get sent as they arrive. So every time we capture a packet, we send it here and it gets stored in the database. Now, a future efficiency improvement would be to bulk these up for maybe 10 seconds and then send them in bulk. It's already designed so that we're sending a list of packets. We just have one packet in the list for right now, but you could certainly implement it that way. The downside is, I mean, you can't wait forever. You probably don't want to wait forever, because if you do have a user interface that is waiting for your packets to arrive, then you don't want to make them wait. If it's 3 minutes, you don't want to make them wait 3 minutes before anything shows up. You kind of want it to be more responsive than that. So let me go back to the code here. This is my worker capture endpoint. So let's look at this stuff here. Now, the first thing to notice, and this is important because I'm going to spend a little bit of time talking about this, I went ahead and did the Swagger stuff. Remember, we're doing all of this because of Swagger. We changed the way that we do these endpoints. In case you missed the Swagger stuff and you're saying, whoa, wait a minute, what are you using a class for with methods for get and post? I thought we were doing it differently. In fact, we were doing it differently when I implemented Swagger, which is this stuff that we're about to look at as soon as I can pull it up right here. This is our Swagger. This, in order to implement this, which is a useful and functional representation of our REST API. See, I can say, like, here's for my capture, I can click on this and it tells me what my inputs need to be. It even shows me what my outputs are going to look like. In this situation, I actually have used it recently, so this is actual data from a request that I made. But if I haven't done that, then this shows you, or it's an attempt to show you exactly what you can expect. And I think this is a good representation of it. This is what the data will look like when we get it back. You will be creating this for people who are going to consume your endpoints. If you implement software and it has a RESTful API, you will be doing something like this. We call it Swagger. It still is called Swagger in some of the documentation and some of the stuff that it creates. It is, I believe they renamed it Open API or something like that. You can look that up. But basically it's the Swagger functionality that we all use, and that is why in the code you have all this extra stuff. It may have been shorter and more concise before, but this is one thing that I want you to notice, and that is that I've done this, and I will tell you that this came in extremely handy in my implementation, so it's nothing to sneeze at. I have no idea where that phrase came from in the United States. If you're not in the United States and you've never heard that and you think that's weird, it probably is, but you can look up the etymology of the phrase nothing to sneeze at. Anyway, I'm digressing again and taking a tangent that I didn't mean to do. So that's one thing I wanted to point out. Another thing I want to point out is this. Look at this. Does this look different? You're probably used to seeing something like this. And I've started to do this. I can't remember if I mentioned this before. For me, I prefer things to be vertically as condensed as possible while still maintaining logic of spacing and things of this nature. I add more spaces in here than some of my colleagues do. I just prefer it and believe it makes it more readable. Other people stuff everything together. And for me, that looks like a big run-on sentence, like a Dostoevsky novel or whatever those are that have one single sentence that's an entire page. There's my bit of culture for you, and I'm probably wrong about it. But anyway, I like to have spaces here, but I also like to not waste a bunch of extra space that I don't need to. And so I prefer to do it like this. I found that I can turn off having PyCharm squawk at me. I suspect if I run my tool, my external tool, to do my formatter, then it will probably put it back the other way, and that's okay. But for right now, I just like to have it this way. So let me point out the few things here. So if there's an IP address that's been given, then I need to get the IP address from target. That's because if you look here, and let me see if I can get to the user interface, I've implemented this so when you click on services, you can come in and look at this. See my target, 8.8.8.8. If I say packet capture, it puts in 8.8.8.8. And as you understand packet capturing, Wireshark and all that, then that makes perfect sense to you. An IP address is good. But hey, what about this? What if I were to try to scan for both HTTPS and this particular endpoint? Well, that's a target. It's not an IP address. So I'm going to have to resolve that at some point in time, and we can go into some of the difficulties and pitfalls that we'll run into here, because a single host name, bbc.com, can have multiple IP addresses, so it sort of falls down. But in my implementation, that is why I have this thing here that says get me the IP address from the target. And now here, I'm just doing a little bit of house cleaning to make sure that everything is as I hope it to be. The number of packets, if it's not given to me, I have to take the port that I got and change it into an integer. And now I can call get capture. Now remember, get capture is what we're going to be calling when we want to display data in this table right here. Let me go back to my devices, and I'm going to do this. And here I suspect I have some packets that I can display. So here you see it's a little bit more interesting stuff going on. That thing that you saw the delay where it was printing this out, but where it was retrieving this data, that is my get packets. It's second. The first thing that happened is I did a post, and post is where I make the request to go do the capture. And we're going to drill down at this in just a minute, but I want you to see the general idea of what I'm doing here. Basically, I get the IP address from the target, I get the capture time. So this is a new parameter that I've added where the user can specify how long do you want me to capture packets for. And I've got that in the user interface. I did mention that the user interface was improved, so you can add stuff here that may usher in some improvements to Quakka, but that's a topic for another time. Anyway, this is what I'm going to do. I'm going to do start capture, and then next we're going to dive down into these and see what they do. All right, let's dive down into these endpoints, actually the stuff that happens inside the code that is driven by the endpoints, in order to understand exactly what's going on. Now there's three things that we're going to be looking at. One of them is the REST call that initiates the packet capture. So somebody makes a request, we're going to end up sending a message out to the, effectively at the end, the Quakka worker who's going to receive this and then perform that functionality. Once it has captured packets, it's going to call back in, and then the second of these REST functionalities will be exercised, and that will be to write the data into the database. And then at some point, the third of these activities will be when the user interface or whatever it is that's making this request comes in and says, hey, get me that data, and we need to go out to the database and do an intelligent set of filtering in order to get the right data and to return it to the user. So let's look at these one at a time and see what's going on. So here is my capture endpoint. So we're going to look at that first. And you recall we have get, which is the last thing that I mentioned in this picture. That's when somebody comes in and says, get me these packets, and we go and make a request to the database. So we're not going to look at that yet. What we're going to look at first is the post. This is what gets the whole thing going. And we looked at this initial part, and here is the important piece, which is where we say start to do the capture. And so let's look at this code that says start capture. So here I am in the worker APIs, and I'm going to start the capture now. Just to take a look around to see where we are, here is start Traceroute, and here is start port scan. So we're in familiar territory to a certain degree. One thing that you'll notice is that these functions that we're calling are actually shorter, and they're shorter because of the fact that I have taken the worker request. Now here's the worker request from Traceroute, where I end up returning the token, but I'm going to be saying send worker request, and I pass in the name of the message broker, and then I pass in the information. So I've put all of this stuff into a common function that these all will call, and that's it right here. So I don't repeat this code over and over again. I had repeated it twice, and I decided, okay, well, I'm being lazy by not putting this in its own function. So I put it in this function. I take as parameters the broker as well as the message. And so I'm going to set up my blocking connection. I'm going to create a channel. We've gone over this. If you want more detail on messaging, go to that lesson where we talked about this. We create the queue, or we associate ourselves with this queue, our channel with the queue, and then we publish what it is that we're sending. We don't have an exchange that we're sending it to. Our routing key is just the name of the Quakka worker, and then the body, that's the important thing, that's the message, that's what gets sent in. So the first time, in the first function, start port scan, what am I passing in? I'm passing in port scan info. In the second situation, start traceroute, what am I passing in to send worker request? I'm passing in traceroute info. And in my last one, which is the one we're looking at here, I'm going to be passing in my capture info. And so basically what's going to happen is this is going to get JSONized, effectively changed from Python into JSON and sent across the wire, and the worker is going to pick it up and act on it. So here we see how we're using this one common function for all three different types of messages. Now, what is that capture information? Let's take a look at what it is that we're passing in. This shouldn't come as a surprise. One of the things we're passing in is Quakka. That is, where is it going to send the packets that it gets. So for each one of these, we're passing in where is this Quakka server. And in my situation, my little situation here, it's running on my local host. Now, if I was truly making these remote, then this would have to be the IP address of the system on which I'm running, and the port, which is 5001 in my situation. But that is how the worker communicates back via what I pass to it. Now, work type is capture in this situation. Work type is traceroute for a traceroute, and it's going to be port scan in the other situation. And then this is my data that is unique to my particular type of work, which is going to be the IP address, the protocol, the port, and the capture time. So basically I'm going to send that down to the worker. The worker is going to perform its functionality, and it's going to send the data back. So that is one side of my Quakka server, what's going on here with my worker APIs. Now, getting the data, basically what I'm going to do is this is where I'm receiving it from the capture worker. It's going to make a REST call and say, hey, here's the packet. I want you to go ahead and do whatever you're going to do with it. As you can see, there's not a whole lot in here. I just get the JSON out of the request, and then I say record capture data, and my record capture data actually has a fair amount of code in here, because what I'm trying to do is I'm trying to take the data that I got from the packet capture functionality, and I'm going to try to um, manipulate the data so that it is a little bit more easily readable. So I'm flattening things. It comes in a highly structured, nested data structure, and in order for me to write it out to the table that I want to write it out, I need to flatten the data. So you can see here I'm taking a dictionary with a key of Ethernet, and then another dictionary item with a key of DST, and I'm flattening it to be part of this packet ether destination. Same thing for Ethernet source. I do the same thing for IP destination and for IP source. And then I go through here and I am extracting things such as destination port and source port. And in certain situations, because we tend to think of HTTPS as a protocol, which it is a protocol, but we have protocols at different levels. TCP itself is a protocol. We have lower level protocols at layer 2, layer 3, layer 4, etc. And so what I'm trying to do is make this friendlier so that when we actually look at the data, the protocol piece is easy to read for a human being. Now, you can argue with me that that maybe isn't the best way to do it, that I should be storing the data in its more raw form, and that's a legitimate argument. We could discuss that, but for my purposes, this is just what I've chosen to do. So there are certain things that I do. I do HTTPS, I do HTTP, I do NTP, I do DHCP. I look to see if there's DNS in the packet. If I see this DNS in the captured packet, then my assumption is that this is going to be a DNS. And so I'm going to set protocol to DNS, the same for ARP and the same for ICMP. And the reason for that is, let's see if I can show you this. I need to have the right user interface. If I were to come over here to services and I was to look and see, I don't know if I have any, I do have packets in here. So this is basically doing DNS. And if you look at the data here, you can see there's a field that I get back that's called DNS. And that helps me to know, that's basically my clue to say that the protocol is actually DNS. You can see in my packet capture, I have changed that to DNS, even though it is probably the layer 3 protocol is going to be UDP port 53. So this is just a friendly translation that I do, and you can agree with it or not agree. That's perfectly fine. I don't have a problem with that, but that's what I did. If I was to go to one of these, which is HTTP, and look at this, I don't know if I have any of them for this. Let's see if I do. For Google, do I have any packets? Oh, I do. Yeah, you can see I've done the same thing for HTTPS here. And as you might expect, I'm doing it, I'm basing it on the port that it is, because you can see there isn't something that says HTTP in it. But here I have a destination port of 443 that tells me to interpret it and to print out HTTPS as this protocol, in case you're wondering about that. All right, so that is where I store it. The last thing that I want to talk to you about is when I get it, and this is somewhat interesting. So this will be my get. This is what happens when the user interface comes in. Oops, I got the wrong one there. Let me put this away and let me find. That didn't help much, did it? This is what happens when we get down to 0 seconds here. We're going to go and do a get and retrieve this. You can see, I think I have a lot of data in there, so it takes a little while, but that is what we're talking about. So let's go back to the code and see what this get does. Once we get down here, basically what I'm going to do is I'm going to say get capture, and I'm passing in the IP address, the protocol, the port, and the number of packets. So let's look at what get capture does. Here's my get capture. And so what I'm going to do is I'm going to go, and what I've done, this is, remember, my database is different between what I'm doing here and what I'm doing in the old Quakka. In the old Quakka, I had a different means of filtering the database. In my Mongo, This is actually quite condensed, and this actually took me a long time over the weekend to work out exactly how to do this in the smallest amount of code possible. Basically, what I say is, if I'm given an IP address, then I'm going to do an OR on IP source equals the IP address, or IP destination. So either one of those. If I'm given a protocol, I'm going to append to this search items things the protocol that I'm looking for, and I'm going to uppercase it. So I'm assuming that the protocol that is stored in the database is in uppercase. And lastly, if I'm given a port, then I'm going to do another OR, and I'm looking for a source port equal to that port, or destination. So here I have my search. All I'm doing is creating my search, and I'm creating this thing to be an AND of all my search items. That's the list here. If there's none, then I need to pass in an empty string here, and then all I need to do is do a find db.captures.find. Remember, in Mongo, I specify this is my database. This is the table. It's not called a table in Mongo. It's called a collection, but that is basically what it is. And then I do a find, and I pass in this search thing, which is going to be a dictionary, and it will be formatted like this. It took me a while to figure out how to do that. Now, last two things to point out, maybe the last two things, that what I want to do with all the data that I get back is, first I'm going to sort it based on the timestamp. So I want to do it in descending order, and then I want to limit it to getting only a certain number of packets, like 10 packets. And I'm realizing this was probably pretty stupid. I should swap these around, huh? I want to do the limit first. If I ended up with 20,000 of these things, then I'm going to sort through 20,000 of them. But if my limit says I only want 10 packets back, then I've just done a lot of sorting that I didn't need to. Although, now that I think about it, I need to do the limit after I do the sorting. So I've just talked myself out of that. You're probably way ahead of me. I need to do the sorting first, obviously, because I want to get all of the most recent items at the very front of this thing, so then I can limit it. So my apologies. I absolutely need to do this sort first. And because I'm lazy, I'll probably just leave it in there. You can see that I'm pretty much an idiot for thinking that I needed to do it differently, but you definitely need to sort it first. What I do have in the original Quakka is I trim older data, so I don't end up with a ton of data in the database. So this is I still need to figure out a way to do that with Mongo. I think I can set something in Mongo to get rid of entries in a collection that are older than a certain time, maybe a day, and I can get rid of those. But anyway, sorry, I'm blabbing on. Hopefully this makes sense about what I did in order to get that data. And then all I do is I need to go through, and I am going to clean up the packets. Remember, the data that we get back from Mongo has some internal fields in it, and it's difficult for Flask to change into JSON format those internal fields, which are classes. So I need to remove them and have only the actual dictionary type data that I care about in the packet. And so that's why I need to go through all of these packets and recreate a list with all of these packets in it. If you've been with me for this whole class, then you can say, wow, I'll bet you could have done that in a nifty list comprehension, and I'm thinking that's probably true. And then I could have, instead of having 4 lines of code, I would have just 1. In fact, I could probably just put it right here at the end, but it might make it more confusing. So for those of you that aren't fans of list comprehension, this may be the way that you like it. Anyway, that is how we do things in our Quokka server functionality. Okay, so one thing I alluded to but didn't go over was the value of this Swagger interface. And the value is this. In my implementation, I had not done the user interface, which took me quite a bit of time in order to implement. And so the question was, how could I find out if my REST API and my communication to my worker and my worker and my worker API and my database and getting the data from the database, how could I test to make sure that that worked? And one way to do it is to use our Swagger API. So here you can see is my Swagger capture. Here's at the top. It just seems to alphabetize them. So I'll just start with this particular one. I can come in here, and because I created it correctly, of course the first time I tried to do this I didn't do it correctly, but if I do it correctly, then I could say something like, show me all of the DNS packets that you have, and I'm not going to worry about anything else, and I'm just going to say, go ahead and execute that. You can see that it is going ahead and doing that, and here's my response. By the way, I got response code 200, and here's the data that I got back. Now I'm looking at this data, and I have to kind of understand what this is, but I can see, okay, well, there's one packet. I see I got that on the 8th. That's a couple of days ago. Here's another one, another DNS packet. So I can see these are my DNS packets that I got. So that seems to be working okay. I think I may have something in there for NTP. So let me try that. I'm going to go ahead and execute it. Again, my response is 200. And this time, if I go and I look at the data that I got back, that also was from a couple of days ago, but you can see this packet is an NTP packet. So getting the data seems to work successfully. Let's take a look. Let's shrink that down, and let's say I want to get some data. So now I'm going to say, okay, well, just to do this as easy as possible, I see this, you can't do that arrow. That's because what I need to do over here is I need to click try it out. I didn't have to do it here up here because I already had done that before. So now it's in try it out phase. And what I'm going to do is I'm going to type in an IP address, 192.168.254.14. That's my laptop. And I'm going to say execute. So this is going to actually cause the request to be made, and the capture time, I'm going to leave that all as a default. So let's see what response I got. I got 200 back. Capture initiated. If you're eagle eye, you can see a bunch of data came back, and now it's going to stop. Whoops. You may or may not be able to see that, but we're actually getting a fair amount of data in these requests coming back in. And if I were to now go and take this, and let's say Control C here. Let's go up to my capture. I'm already in try it out mode. I'm going to get rid of NTP, and I'm going to put in this IP address. Let's see if this works. So I got a 200 back. It seems to have worked. Let's look at the data that I got back. So sure enough, this is saying that this source address is the one that I was actually looking for. Let's go down to the next one, and here the destination address is the one that I'm looking for. And down here, again, another packet with that destination address. And here's one where that's the destination address. Seems like there's some communication going on between these particular devices. So you can see that I did end up with a bunch of these packets. I think by default I get, oh, and here it is as the source. So there's communication going back and forth. I only have, by default, my number of packets is 10. So in the GUI I have like 1,000, but this only has 10. But you can see now what am I able to do? I'm able to test all of this functionality even though I don't have the user interface built. So the moral of the story here is if I'm the back end and the business logic guy that does all of this stuff, and I have some other dweeby guy that does the user interface stuff. I say that because my kids both do user interface stuff, and somebody else is doing it, and I want to make sure that it works correctly. I can test it out myself. In addition, when I tell my colleague what I've done, if I have a Swagger interface, then they can actually test this out and they can see, oh yeah, all right, that's what I wasn't expecting that. Now I see that's what I get back. I will write my code appropriate to receive that, or whatever it might be. So very useful tool, this Swagger stuff. I highly recommend it. Okay, so we've talked about the Quokka server functionality. We talked about the endpoints that we have for doing stuff in chronological order. We looked at the endpoint that actually sends a message out to the worker to get stuff done. We looked at how the worker sends data back and we store it in the database. And we looked at how we actually, the user interface, can come in and do filters and sorts and limiting of the data that it sends back. So we've looked at all of that stuff. Now that all that remains is for me to talk about capture and the user interface, which I'm only going to mainly wave my hands at. This capture functionality, just like with port scan and just like with Traceroute, is basically taken from the functionality that exists in the original Quakka you see down here. So I basically did the same thing that I did with port scan and Traceroute. The code itself that you can take a look at is here in the capture thread. Primarily, there's also a utility function that performs things. In our situation, we're going to be doing a send capture, so that is something that we end up doing. And we also have this get packets from capture, so there's a little bit of stuff going on there. But basically, that's what we do. Capture thread is the thing that actually does the capturing, and this hasn't fundamentally changed from the way that it works in Quakka itself. So I didn't have to modify that too much. We're not going to go into it in any detail really right now. The user interface is a little bit different because if you look here, the user interface, we have an entirely new thing over here. So we added to device, hosts, and services, we added capture. Now, if you look at this, you can say, that looks pretty similar to the other things. They're basically a table. And you're right, they are. It's just a table, so there's nothing new to see there. Now, what is a little bit new is that I added functionality to do capturing of packets from devices, from hosts. So you can do a packet capture from services. You can do a packet capture as well. And then within the actual capture screen, I figured out how to do input and how to do these nifty placeholder values, so that like if I were to say I don't want to do it like this, I just want to backspace and get this out of there. Then once I've gotten rid of it, it goes back to the placeholder, which is IP. You can type things in here if you want. I can type in any arbitrary IP address, or I could leave it blank, and I could just start a capture from here, and it would begin to go get me all the HTTPS data that exists out on the network. And as you can see here, this is actually updating. Hopefully you can see that, and we're getting new packets all the time. And if I were to go here and I was to say, give me a refresh of this, look at my date. It's 5/6 is the last time that I did this. I'm going to say, get me some new data. And assuming that this works correctly, 5/10, that is what today is. 9:35 is the time that it is my time. So here you can see a bunch of HTTPS stuff from a number of different devices. Actually, I'm seeing a couple of different devices right now, and you can see there's 1,000 of those, so we have a lot of things in the database as it is. Anyway, that's the user interface. The code for the user interface, I did need to add this capture.javascript. So this capture code is new, and we've gone over user interface. It hasn't been of huge interest to everybody, so I'm not going to go over it in great detail. It does have similarities with some of the other stuff, like getting a traceroute, getting a port scan. It's pretty similar to that. I did have to modify devices to add functionality to do something when somebody requests doing a capture. I have to call this render capture. I needed to add this information down here for actions, which is the tooltip capture packets for host. But yeah, that's just an initial pointer in case you want to go into that. But that in a nutshell is packet capture. So basically we implemented this. We have our Quakka server, quokka-prime, whatever we call it, getting a little bit further down the path. Packet capture, of course, will be useful when we're snooping traffic and trying to see if there's any exposed passwords, so that, of course, because we're good ethical people, we would attempt to close those potential leaks and vulnerability to exploits. So that is packet capture. Hopefully it made sense. If not, feel free to let me know whatever questions that you might have. Thanks for listening.